Welcome student in this digital lecture series. Myself Dr. K. Dadure, Assistant Professor, Bajaj College of Science, Wardha. So today I am going to deliver a topic of Pearson concept of HHSAB principles, and we will see here in this before we are going to discuss these Pearson concepts. So students, we already know in our previous class how the acid and bases categorize, and they are categorized on the basis of Levi's concept of acid and bases. And we all know that the Levi's acid basis is actually the reaction which is taken place by formation of the coordinated bond. Okay, and in this we know that the bases act as a donor and acid is act as an acceptor of electron pairs, and on the basis of this property we classified the hard and soft acid and bases. But here in this topic, the Pearson actually gave a very simple principle for the reaction is between the acid and bases, and this principle is states that hard acid is preferred to combine with the hard bases, whereas the soft acid is preferred to combine with soft bases. Okay, but one thing remember students, it should be noted that this principle states only the preferential choices of the acid and bases to form a complexes. Only the preferential choices. It means that it does not mean that the soft and hard combination is never exist. Okay, in somewhere the soft and hard combination is exist. Okay, it is just the preferential choices through which we making the bond in between the acid and bases, and acid and base here. So in the 1963 the R.G. Pearson is extended and generalized the qualitative correlations between the Levi's acid and Levi's bases by classifying them into the two categories, that is the hard and soft. Pearson also suggests a very simple rule, and that rule comes out into the form of Pearson principle, and that is what? For the predicting the stability of the complex, which is the form between the hard and soft acid and bases. So what he stated? He stated the hard acid is preferred to bind with the hard bases, and soft acid is preferred to bind with the soft bases and gives a stable compound and a stable complex compound. So through this circular diagram we can see that, so very simply this HHSAB principle. So here we can see the hard and hard combination is preferable and soft combination is preferable with respect to the soft and hard acid and bases. Okay, so here the preference study we have shown by this way. So here we can see that the hard and soft combination is not preferred, but hard bases and soft combination is not preferred. Okay, so this is actually the very simple way we can understand how the hard acid and hard bases they prefer to make the bonding, and how the soft acid and soft bases they actually prefer to make the bonding. And on the basis of that, the Pearson is actually classified the different classes of hard and soft acids, and they categorize the class A and then class B, where all the class A categories of the hard acid he has placed, and in the B class he placed all the B category of soft acids. And we already know that students, so in between this A and B, those elements are actually comes out that actually called as the borderline. They actually coming in the borderline area, and they actually sometimes they possessing the properties of both and sometimes not. So it is not necessary and compulsory. Either intermediate species which is coming between this class A and class B, they possess the properties of both this class. Okay, this is one of the point here. Let's see some combining ideas of the Pearsons, and in that he actually give us the information regarding to the hard Levi's acids and soft Levi's acids, some related points. So what about the hard Levi's acids? The hard Lewis acid actually having the very small ionic in radius, okay, and small ionic radius, it means that the small atomic in size, and when a small atomic in size, they have high positive in the charge, and in such a case the species do not contain the electron pair in their valence shells, okay. And the next point, the low electron affinity. The electron affinity as far as the hard Lewis acid is concerned is having low electron affinity, and they are very strongly solvation properties, and they showing the very strongly solvation property and producing the high energy, okay, after we can say the solvations. And soft Lewis acid, this is the larger atomic size and radius. They having the lower partial delta positive charge, their partial positive charge is there, and they having electron pair in the valence shell, okay. They having the electron pair in the valence shell. As far as the lone pair is concerned, we can see in the examples, and easy to polarize, and they are easy to oxidize, okay. As far as the larger atomic size is concerned, the electron in this shell is very loosely attached, and due to this loose electronic arrangement, such an shell is very easily polarized and easily oxidized. What about the hard Lewis bases? So hard Lewis bases having the small and highly solvating property, and electronegative atomic, and electronegativity is around the 3.0 to 4.0, okay. And such a species are very weakly polarizable, okay. Very weakly polarizable means less atomic in size, so polarization always in a less amount, and very difficult to oxidize. Definitely when the polarization will be less, so oxidation will be definitely less, and high energy, highest occupied molecule, and they actually the energy is occupied in the highest occupied molecular orbitals, okay. Soft Lewis bases, they having the larger atoms in atomic in size, and around 2.5 to 3.0 is the electronegativity. They are easily polarized and oxidized, and they having the low energy highest molecular orbitals, but larger magnitude highest occupied molecular orbital coefficients, okay. This is all about the hard Lewis bases and soft Lewis bases characteristics points. So one important note which here I want to discuss, as I already discussed in the previous slides, the borderline species means the species which is actually the coming in between the hard and soft categories. They having the intermediate property, but that intermediate property is not always necessary. They will possess, okay. So this is actually the point related to the borderline species. Now the most important, and that is applications of HHSAB principle. So student, in this application, the first application is stability of the complex, and in this we can see that here we can see that the AgI is the complex which is the stable, and AgF2 is not stable comparatively. So we will see the description related to the AgI. As far as the AgI2 is concerned, so Ag is the soft acid and I is actually the soft base, okay. So when the Ag plus 2I react, so we can say that the soft acid is react with the soft base, and during this reaction those product will form, that product or complex will be soft and soft interaction, and we know that the soft interaction always preferable and stable, and that is the reason the AgI2 exists as the stable complex, while the AgF2 does not exist, because as far as the Ag is the soft acid and fluoride is actually the hard basis. So here soft and hard combination is not preferable, and during the interaction of this soft and hard, the complex which is formed, which is comparatively not stable, okay, and comparatively AgI2 is not stable and it is the unstable. In the COF6 complex, which is the more stable than the COI6 complex, here also we will see the hard acid is actually the CO, okay, which is interact with the hard base F, okay. So hard and hard combination always preferable and giving the stable complex, and that is the reason the COF6 is the stable in the nature, as compared to the COI6. Okay, because the CO is actually the hard acid and I is actually the soft base. So hard and soft actually not preferable as far as the stability is concerned, and that is the reason the COI6 is unstable in the nature. Okay, so let's see the symbiosis. So students, this is again the very important application. In this application we will see first what is the symbiosis. So as far as the term symbiosis is concerned, symbiosis is the process where the soft ligand have a tendency to combine with a center which is already associated with the soft ligand, and hard ligand have a tendency to combine with the center already associated with the hard ligand. Okay, and this tendency has been termed as symbiosis. And in this symbiosis we can see the example in this reaction. This is a BF3H and BF4 BH twice. So in this case we can see that this BF3 is the hard acid which is combined with the hard base, that is the fluoride ions, and here in this BH, okay, in this BH they are the soft acid and they prefer to join the soft base H. Okay, these are the soft acid and they prefer to join the soft base hydride ions. So in this way this symbiosis process is going on, and number of the reaction we can see as per this symbiotic pathway. Now the next is to predict the course of the reactions. So in the nature and in the chemical, in the chemistry there are a number of chemical reactions. So through this way we can predict the number of chemical reactions. How to predict? So these are the simple reaction which I have given here. This is this 1 and 2. In that we can see that the first reaction is actually goes to the right because the hard acid H is actually they bind strongly to hard base OH. This H is strongly bind to this hard base OH and to produce the water molecule, okay, which is the stable compound. Get it? And that is the reason the reaction is goes to the right hand side. But on the other hand, the reaction basically is favor to the left hand side, and the reason is here the soft base SH, soft base this SH will tends to remain combines with the soft acid CH3Hg. They are tends to remain in this CH3Hg, and instead of the joining to the hard acid H, okay, instead of joining to the hard acid H, and that is the reason. So here the reaction is proceeding in the left hand side. So we can, in this we can predict the number of chemical reactions and their feasibility as per their directions. Okay. Now the next is the relative strength of the hydro acids. In that hydro acid, the very well known hydro acid, we already know that this is a HF, HCl, HBr and HI. So just simple by just knowing this reaction we can see how the hydro acids tendency is increasing and decreasing according to its acidity. So here we can see that the simple reaction where HX and H2O, HX is actually this is a hydro acid which is react with the water, and simply H3O ion, that is a hydronium ion, is produced, and halide actually dissociate at the end. So basically here in this case the hardest base is hardest base is actually the fluoride, and they will be the more successfully and strongly the bond to the hard acid H plus. Okay, they are basically the combination of hard we can say the hard base and hard acid, and hence the HF will be the highly stable, and due to this hard combination this HF is very highly stable, and therefore when the stability will be the here achieved, so the dissociation property will be the less, and therefore it least dissociated, and hence the acid strength is increases. Okay, least dissociated and acid strength is actually the increases, as this HF is less than HCl and this HCl is less than HBr and this HBr is less than HI. And in this way the strength of the hydro acids we can calculate. Now the next important one, again, how to predict the directions of the inorganic reactions. So students, in this two simple reactions, I would like to show you the predictions of directions in the inorganic reactions. So here simple ASF3 plus PI3, which giving you the ASI3 and PF3. In this first case, before we going to discuss this phenomenon, so basically the HHSAB principle is used to predict the outcome of the few of the reactions, okay, and we can predict whether the reaction is proceed to the right or left based on the soft or hard acid-base interactions. So here we will see how the acid and base interaction is taking place. So here in the reaction in between the ASF3 and PI3 is possible. It means proceed to the right hand side and to the right hand way, because AS3 is actually the softer than P3 plus ion, or we can say this is the P. AS3 plus is actually softer than this P, and iodine, this is I, is the softer than fluorine. Okay, and that is the reason this reaction is, we can predict, and this we can say that the reaction will be the proceed further. Okay, in this second case, the reaction in between this magnesium sulfide and barium oxide, okay, it is possible because this magnesium 2 plus is actually the harder acid than the barium, and this oxygen is actually the harder base than the sulfide. Okay, and that is the reason they are interacting and they proceed further. So in this way we can predict the directions of the number of different inorganic reactions. Then after types of ores, students, as far as the ore is concerned, we already know that in the nature there are the different ores combination is taken place, and we know that the hard metal is preferred to bind with the hard anion, and thus they are available as oxides or fluorides or carbonates or silicates in the nature, whereas the soft metal prefers to bind with this soft anion, and hence they are found in the nature as sulfides or phosphides or selenoids. Okay, this is actually the combination of the ore in our nature. So in that I would like to explain you one of the very interesting example of aluminium. So aluminium is the mostly the bound in the nature as a alumina. We all know that. That means Al2O3, which is the oxide ore. Since because the Al3 plus is actually the hard metal, which is the preferred to combine with hard oxide anion rather than the soft sulfide ion, and that is the reason the alumina as an oxide is found in the nature. In case of the silver and copper metal, they exist as a sulfide ore. Okay, they exist as a sulfide ore. Why? Because both this silver and the copper are the soft metals. Okay, this is the reason the ore are actually in the nature is found in their different combinations. Then after the solubility, so as far as the solubility is concerned, we all know that in our simple language the solubility always prefer the one simple concept, polar, non-polar and non-polar, but here the case is something different. Here we can see that in the case of solubility, the hard solvent is always preferred to dissolve the hard solids, and soft solvent dissolve the soft solid. And example is this is the silver hydroxide, which is dissolved in the acidified aqueous solvent, but the silver sulfide which does not dissolve, and that is the reason the hard and soft combination is preferable. In the next case, hydrogen bonding. So strong hydrogen bond is possible in the water molecule and ammonia and in the HF. So why this property is actually the most we can see here because the donor atom, that fluoride, oxide or nitrogen, oxygen and nitrogen, they are hard Lewis bases, and their interaction with partially positively charged hydrogen, and that is the reason which is the hard acid and are stronger. Okay, and due to this reason the hydrogen bonding is very strong in the water and ammonia and HF molecules. Then after the linkage of the ambidentate ligands to the metal atoms. As far as the ambidentate ligand is concerned, students, we know that the ambidentate ligand is the category of the ligand which actually having the two donor side. So in that we are taking the example of the thiocyanide, and here the thiocyanide is actually binding from two sides, some from sulfur and some of the time from the sulfur end and some of the time from the nitrogen end. So when the bonding mode is determined by using the HHSAB principle, so it bonds through a sulfur atom, which is the soft base, and when bonds through the sulfur atom, okay, which is the soft base, and they bond it to the platinum 2+ ion, which is the soft acid. That means the soft base is interacting with the soft acid, this platinum ion. But however, when it bonds through the nitrogen atom, okay, which is the hard base, so that time it prefer to link to the chromium 3+, which is the hard acids, and in such a way this ambidentate ligands actually interacting with soft to soft and hard to hard. So students, after applications, so limitation is also in the HHSAB. So what are the limitations? So here there are a number of different limitations in the books, but I selectively put out some selected points related to the limitation point of view. So according to this HHSAB principle, here the barium ion is actually hard acid and expected to show the charge controlled bonding that result the more ionic nature for the beryllium compound as far as the HHSAB principle is concerned. But this is not true, and somewhere the thing is different. In the second case, hydrogen ion H+ is actually the hard acid, and hydride ion H- is the soft basis. So according to this HHSAB principle, the interactions between them must be the polar covalent, and hydrogen must be unstable. Indeed, H2 is the stable molecule with the pure covalent nature. So this is actually the limitations regarding to the as far as the HHSAB principle is concerned. Some more limitation related to the reaction point of view. Here we can see that the hard or soft factor, basically according to the HHSAB principle, they are independent. Okay, they are independent of acidic or basic character of the compound. Okay, so it depends upon how much the acidity and how much the basicity, particularly with respect to that acid compound is there on the species. The hard and soft factor is actually the interacting. But however, sometimes this rule is violated by the inherent acid or base strength and leading to the more stable hard soft system. So in this we can see that this is the example, and in this example this reaction is not favored. Here the SO3 twice negative, which is the soft base, and HF is the hard. Here we can see that this HSO3 negative, hard and soft, and at the end this hard. So here we can see that this reaction is not feasible and not favored, and that is the reason there are so many disadvantage of this HHSAB principle also, and limitation also. So at the end, students, I would request you to go through this important YouTube links and more of this also, so that you can understand this topic in more detail. So as far as the examination point of view is concerned, this is the sufficient knowledge. But as far as your competitive examination point of view, so student, this topic is also very important. So please go through this YouTube links and watch and listen carefully. So thank you students, thank you very much.